Today's videos we are solving a really cool recursive grid problem that you can see. You just pause this video and go through the statement so you will understand the code very well. So this problem is called a special grid, right? And the statement saying that you are given a non-negative integers n representing this grid 2 to the power n into 2 to the power n, and you must fill the grid with the integers 0 to 2 to the power n minus 1 to make it special, right? So a grid is special if it satisfies all the following conditions that we have given, right? So these statements are very important for you to understand, right? And then it is saying return the special 2 to the power n into 2 to the power n grid, and any 1 into 1 grid is also special. Okay, so what are the points are there? So all the numbers in the top right quadrants are smaller than the bottom right. Similarly, bottom right quadrants are less than bottom left quadrant, and bottom left quadrant are less than top left quadrant. So you keep in mind this because this will help you to understand the problem explanation that I am going to do. So let's understand. You are given n, right? What we have given? We have given an integer n, your number n, and our goal is to create a grid of this one, right? This 2 to the power n into 2 to the power n, right? From 0 to 2 to the power n minus 1, right? We have to do that, and we have to fill with the unique numbers, right? From 0 to 2 to the power n minus 1. Gotcha? Means first of all we have to create this, and you have to fill with the unique numbers, right? So that we can make the special. But here is the twist. The grid must follow the 4 special rules that we have given here, right? What is the rule first? So first of all, we have given the top right quadrant must have a smaller number than the bottom right. Means top right quadrant must have smaller number than the bottom right. Then what we have given? Right, first we have given top right corner and bottom right corner, right? And then we have the bottom right corner must be the smaller than bottom left one, and then we have bottom left must be smaller than top left, and finally each quadrant must also recursively be a special grid. Sounds complicated, right? But don't worry, we will break it down step by step so you will understand. So this problem belongs to divide and conquer, right? And if you assume like let's suppose you have 2 into 2 grid, and we will divide into quadrants. Let's suppose q1, q2, q3, q4, like 4 quadrants are there. So this is a classical divide and conquer problem. If you have already solved like this, so you will understand. So at every level we split the grid into 4 quadrants, right? q1, q2, q3 and q4. So each quadrant is of size 2 to the power n minus 1 into 2 to the power n minus 1, and it will be a special grid, right? If each quadrant having the size like this, right? So each quadrant will take 2 to the power n 2 to the power n minus 1 into 2 to the power n minus 1, right? That we will do that, and we will make the grid that we need to represent, right? So we generate the quadrant recursively and assign the value like this. Let's suppose the top right quadrant, let's suppose the top right is a smaller values, means q1 have the smaller value. Let's suppose the bottom right that we are talking about, the bottom right quadrant, so this is called q2. So bottom right corner is slightly larger than the smaller one, means q1 values are greater than q2, right? No, sorry, q1 is smaller than q2, right? And so the third we will take is a bottom right quadrant, right? That is called bottom left, you can say. We can say bottom left here, and then the bottom right quadrant. Okay, so bottom right should be smaller one, right? So bottom right is slightly greater than the bottom top right, right? And so we will create the bottom left as a even larger than the bottom right. Means first of all think that q1 is a top right, okay, and bottom right is you can represent here, but I'll deep dive into the, you can say, another video to understand this problem. But just think like q1 will be the top right, and which will be the smaller values, q2 will be the bottom right, and it is slightly larger than the top right. Okay, then we'll take a q3 that is bottom right, and it will be even larger, and the top left will be the largest, that will be the q4. So this keeps the rules satisfied for the entire grid, and for each subgrid that we have given, the rules we have given. Okay, so let's understand the coding part. Okay, so coding is what we have to do. First of all, we will write the code to generate the grid, right? To generate the grid, what we have to do, we have to calculate its size, right? So how will you get the size? You have already given int n, right? So int n we have given, so we have to calculate the size of grid 2 to the power n. So as we have the power math.power function, right? So math power function is 2 to the power n. So what you will do, you can do like this. One is left shift of n, right? And you will get the size. And to build the grid, you have to do a recursive function. So you will create a build grid, a recursive function, and this build grid will do the rest of the thing. So we'll provide the size and the start from where we will start, right? So in the base condition, what we have to do, 1 into 1 grid also special, so you can fill it with the start, right? So you just think this is the you can say start that we are passing. So we are passing 0, and so we will fill this grid as a 0 0. Okay, and then what we will do, as you can see here, right? Then let me do like this. Okay, here. Okay, so now you can think in the step 3, what we have to do, first of all, we'll build the base case. We'll create a 1 to 1 grid, 1 into 1 grid to make it a special, and then we'll go with the divide and divide the grid into 4 quadrants, right? And so we'll take a half size into size by 2, we'll get the half, and area will come half into half, right? So you know the half of the element will be here in this area. So number of element in each quadrant will get here in the area, because half into half will get the number of element in each quadrants, right? So to build the quadrant, what we have to do, we have to say q1, q2, q3, q4, right? And so that I was saying, in the q1 we'll have a smaller values, in q2 we'll have a slightly larger value, and in q3 we'll have even larger, and then q4 have the largest. And for that you just need to plug some values. So if we will building the grid, so just we'll start half and start. Will in the building, when we are building the grid, we'll pass what the size we will keep the size same, but only will start will get changed. Okay, so we'll start from the area. In another one, we will do start plus 2 into area and 3 into area, like that we will keep updating. So we'll get the condition in increasing order. q1, q2, q3, q4 is in the increasing order, right? It means q4 will be the largest and q1 will be the smallest, right? That we will do. So this keeps the rule satisfied for the entire grid and for each subgrid. You got the point, right? So this subgrid, or you can say each quadrant will be satisfied with the rules. Okay, now you have to merge the quadrants into one full grid, and for that you have to make a final grid equal to new size into size, right? And you know the size is already given, that we have already calculated, right? Math.power 2 to the power n, right? You can do the same thing. Okay, and then once you merge these ones, how you're going to merge, you will for all I and j you will go, and you have to place the top left quadrant. How will you provide the top left? So you have to start from the top left, right? So from the top left you will grid at ij, you will store that. Then we have to place the top right. So how you're going to push, so you have to write grid ij, right? I will be the same thing, but j will be j plus half. So you can start with the top right, and so we'll store the value here, top right. Similarly, to place the left quadrant, right, what you have to do, I plus half at j, and you will add the bottom left. And after that you have to place the bottom right quadrant. So to do that, I plus half and j plus half, so you will have the bottom right corner, and then you will add all the values of bottom right ij, right? So in this way you can merge all these codes, right, in and you can build the grid, and finally you will return this grid. There is a utility method that you can print and you can see. So if you want to print the grid, just you need to make a print method, so you can debug easily, and you can store, like you can just make a grid, right, and you can print it. So whenever you create a main method, you just call this method to print your things, so you can understand what you are doing. Okay, just go through the code, walk through your line by line the code and understand, right? So what we have done here, we define a helper function that is called build grid to build the grid, and we will pass the size and the start, right? So it will return a special grid from a given number, that the number is given, this is number, and the number we got from the, to make it size, right? Math.power you can do. All right, or left shift. So for the base case, if the size is 1, we return the start value as a single cell grid, right? And then we calculate the size of each quadrant recursively and build them. Then we merge all the we merge all 4 into the final grid, and we'll placing them the value, right, in that order. So first we'll place the top left, then top right, then bottom left and bottom right. Like that we will add, and finally we will add a method. We are adding a method, print grid, a method to visualize you to the output, and you test your values, right? So you just put some values, right, and you just put, let's suppose n equal to 2, and you will get a grid 4 into 4 cross, similar like some function will like you will get some values. Okay, so let me know if you need the deep dive into this video, and thank you for watching this video, guys. Let's continue the contest.